Hello there. This is probably going to be my last video in the matrix series, at least for a while, because I think I've covered all the elementary matrix stuff that there is to cover. There's some other topics I want to cover, but they're not so pressing right now, and will be the last one. Over the last few videos, I've talked about how the determinant is important because it helps us not only calculate the inverse, but initially it indicates if there even is an inverse. If our determinant ends up being 0, then it will not have an inverse. This was a result of us using scalar multiplication of 1 over the determinant in our inverse process. Well, if our determinant is 0, that's 1 over 0, and we can't divide by 0. This is an indication of if it even has an inverse. If it's anything but 0, it will have an inverse. Okay? Now, this does a lot of things for us. One, if we don't have an inverse, we can't solve a system of linear equations. That equation has no solution. And so what I want to do today is to show you that this augmented matrix, that is the setup of an inverse, that is the setup of a system of linear equations, has no solution. And then to confirm, we will demonstrate by finding the determinant. But first, I'm going to start with elementary row operations. I can see I've already got my 1 here, so I'm just going to go ahead and start by taking row 2 and replacing it with row 1 times -3 plus row 2. Okay, and this will give us 1, 1, 1, and 3, and then 1, -2, -5, and 1, and only row 3 will change. So we got -3 plus 3 gives us the 0 there. That's good. -3 plus 2 gives us the -1. And then -3 plus 1 gives us the -2. And then -6 plus 3 gives us -3. Okay, so let's go ahead and work on getting this to be 0. We'll do that by, this time I'll actually subtract. So row 1 minus row 3 so that it's a little bit more clear. So 1, 1, 1, 3, 0, -1, -2, -3. Those will stay the same because we're not doing anything to those. 1 minus 1 is 0. Great. 1 minus a -2. That'd be the same as 1 plus 2. So that is a 3. And then 1 minus a -5. That's 1 plus 5. That gives us a 6. And then 3 minus 1 is 2. Now, I hope we're seeing why this might not have a solution set. The next thing for me to do is to find this becoming 0. So I'm going to take row 2. I'm going to multiply it by +3 and add it to row 3. If you don't see it yet, you will here in a second. So row 1's not changing. 0, -1, -2, and -3. So row 2 is not changing, so 0 plus 0, that's fine, 0. -1 times 3 is a -3, plus a 3 gives me 0, precisely what we want. But now here's the problem. -2 times 3 is -6, plus the 6 also gives me 0. And for good measure, -3 times 3 is -9. -9 plus 2 is -7, and we don't have a value where we can get this to be 1. So this is what would happen if you didn't know that a matrix didn't have an inverse, if you didn't calculate its determinant, then looking at this, you would see, okay, I've gotten to a point where I can't get my identity matrix. If I can't get my identity matrix, it doesn't have an inverse and therefore will not have a solution. To confirm, let's calculate the determinant. So that was 1, 1, 1, 3, 2, 1, and 1, -2, -5. Okay, let's go ahead and use our method. So this is equal to 1 times the 2 by 2 determinant of 2, 1, -2, -5, minus, we got a 1 times the determinant of 3, 1, 1, -5, 1, 1, -5, and then plus, and we'll use our last one to get 3, 2, 1, -2. So we got 1 times the 2 by 2 determinant of 3, 2, 1, negative 2. Okay, let's go ahead and do these 2 by 2 determinants. We got negative 10 minus a negative 2, so negative 10 minus a negative 2. And I'm not going to go ahead and write the ones in. Multiplying by 1 is itself, so minus, we got negative 15 minus 1. And then we've got negative 6 minus 2. So let's see what that ends up being. So this is a plus. Negative 10 plus 2 is negative 8. Negative 15 minus 1 is a negative 16, but then we got this negative right here. So that's plus 16. And then negative 6 minus 2 is a negative 8. We'll just change that to minus 8. And we can already see it. 16 minus 8 is 8. Negative 8 plus 8 gives me 0. And we can see this will have no inverse, and therefore that original system will have no solutions. If you like this video, go ahead, give it a thumbs up, and subscribe to the channel. If you want to see more content like this, leave a comment down in the comment section, and I'll see you for the next video. Thanks for watching.